Now on number 1 here, it says factor each completely. Now that's a hit each completely. There might be more than one step. And if you notice on the first one, a 2, a 14, a 36, those are all odd. Or excuse me, even. Jeez. Early on a Monday morning here, sorry. So I can divide those off like let's try this again. There we go. And inside the parentheses, that's a trinomial. So we can factor it again. It'll be x plus 9 and x minus 2. 9 minus 2 is 7. 9 times 2 is 18. And then just don't forget to bring that GCF, that 2 down. First thing you always want to look for is a GCF when you're factoring. On 2, though, there's no GCF. 8 times 3 is 24. 8 plus 3 is 11. But it's negative 11, minus 11, so they're both going to be minuses. Now on 3, well, there's a 25 and a 1. There's no GCF there, but hey, 25 is a perfect square. So is 1. So that's dots. 5a plus 1 and 5a minus 1. And 4, certainly if you recognize that number 3 was dots, you recognize number 4 as dots. R plus 2 and R minus 2. And, you know, you can put the minus first. Doesn't matter. You have the plus first. Just as long as you have one of each. All right. Moving on here, let's see. So on 5, for what values of the variable will the following be undefined? Now, number 5, we just set the denominator equal to 0. You can't divide by 0. So if the bottom was equal to 0, like, and you tried to calculate that on your calculator, you get an error. That's what this is asking for. A lot of times people confuse the undefined values with the simplified because they both have the fractions with those polynomials in them. Undefined values, set the bottom equal to 0. Then it's up to you to figure out how to solve it. But hopefully this one's easy. It's just x minus 5, linear equation, 1 step, add 5. 6, forget about the top. Like I said, you know, it's just set the bottom equal to 0. You figure out how to solve it. Now, this is a quadratic equation. We have a square variable. The first way, and the only way we've reviewed this year, the first way you ever learned how to solve these was by factoring. Now, on the first 4, after we factored, we stopped. There was no equal 0. There wasn't even an equal sign or anything. So you stop with the parentheses. Here, it's an equation. It's equal to 0. So you factor, it'll be minus 6 and plus 3 on the factors. This is when you have to keep going. K could equal, or K, not X, should be speaking right at the same time, I guess. K could equal positive 6, or K could equal negative 3. You know, it's like I was saying earlier when we went over this. As we go along and we learn new things, they can put other kinds of equations on that bottom, and it's up to you to figure out how to solve it. So just undefined values. Set the bottom equal to 0, then identify how to solve it and solve it. 7, we're adding some fractions. So we have to get a common denominator. Well, for the number part, we have a 3 and a 6. You know, if you kind of blank out on what to do with this, you could always just multiply them by each other. That will work. But if you recognize, hey, I can turn a 3 into a 6 easily by multiplying by 2, that'll save you some work. Also, that first fraction needs x cubed, so I'm going to multiply the first one by 2x cubed, top and bottom. I don't even have to do anything to the second one. It'll match the first one after I just take care of the first one. So on top, we got 8x cubed y. Yx cubed would be fine. The bottom, 6x cubed. Like I said, now, you don't even need to do anything to the second one. It's already the same as the first one. Now that they have a common denominator, we can add, we can smush those together, but you can't really do anything to add them since they are not like terms. We're just going to say 8x cubed y plus 3x all over 6x cubed. Number 8. Well, number 8's a little bit harder. We got those polynomials. And when we learned this, we said, you know, look to see if you can factor and if there's any reason to factor. Like if the second fraction was just 2/5 with no x plus 5, just 2 over 5, I wouldn't want to factor the first one. You know, I just have to multiply by that polynomial on the second one. But since there is an x plus 5, there might be a chance that one of those factors of the x squared plus 2x minus 15 will match. And it turns out 5 minus 3 is 2. 5 times 3 is 15. Those factors are for that first fraction's denominator. And as you can see, hey, now the first one has an x plus 5, and so does the second one. The only thing I need to do to make them match, multiply the second by x minus 3. For the denominator here, they're both x plus 5 times x minus 3. Let's say it's a multiple choice. Maybe they would write x squared plus 2x minus 15. That's what you would get if you did that double distribution. You don't have to go through all that, though. You know x plus 5 times x minus 3 is x squared plus 2x minus 15 because you just factored it. Just like if you factor 6 into 2 times 3, you know 2 times 3 is 6. Anyway, this is multiple choice. I'll just write it down as factors still. Distribute that too. Hey, I can actually combine some terms here. 2x plus 2x is 4x. I'll put them together into one fraction. Negative 3 plus negative 6, negative 9. And again, you know, if that was a multiple choice question, or if it was written out one and it said express it, the top and the bottom, the numerator and the denominator as a polynomial, you'd have to write x squared plus 2x minus 15. That's what the x plus 5 times x minus 3 is. Now 9. Again, we have these two trinomials here. Now, since there's also an n plus 1, you know that we got a factor. Just in case one of the factors of the trinomials is n plus 1, and it turns out it is, because 3 times 1 is 3, 3 plus 1 is 4. So these two are n plus 3 and n plus 1. Well, they already match. And now that we factored, we can see that, hey, the leading fraction is 1 over n plus 1. So it has the n plus 1 that the others do. It just needs an n plus 3. Don't forget to distribute, but it is just a 1, so that's really easy distribution. 1 times n, 1 times 3. Now, I'm trying to show a lot here just to illustrate what's going on. But once you're good at this, like if you understand how this all works, if you didn't want to write those separate, I'm talking about the left side here, because we're just going to put those together on the next step anyway. If you skipped what I just wrote and went right to what I'm writing now, n plus 4, that's fine. Now, like we said in class, if those two fractions are equal, it means they're the same thing. They're equal. If the bottoms are already the same, if the bottoms are equal, then the tops must be. So you just drop the bottom. Hey, this one's nice and easy to solve. Subtract 4, negative 2. Well, don't worry about the excluded values there. We'll just go over the simplified part here. Like I said, sometimes people get the simplified and the undefined values kind of mixed up in their heads. Simplify is we're going to try to reduce that fraction down, maybe cancel some stuff out, but you have all those pluses mixed in with division. Now, those don't undo each other. So you have to factor. Because factoring breaks something up. Sorry about that. Factoring breaks something up into multiplication. And multiplication and division do cancel each other out. So when you're simplifying a rational with all the polynomials, you got to factor. Top, 1 times 1 is 1. 1 plus 1 is 2. Bottom, 2 times 1 is 2. 2 plus 1 is 3. One of the x plus 1s cancel out. The other one's left over. Done. Eleven divide, there will be no remainder. So let's see. So we're dividing by a binomial. That means my first part of my answer has to go here in 2 terms. And you want to make n match 3n cubed. So we'll multiply it by 3n squared. Don't forget to distribute 3 times 2, 6n squared. Now this is always subtraction. 3 minus 3 cancels. Negative 3 minus 6 minus positive 6 is just negative 3 minus 6, which is negative 9. Bring the 22 down. Well, I got to make n match -9 n squared. So -9 n. -9 times -2 is -18. Now be careful here. This time, it's minus -18, which makes it plus 18. -22 plus 18, -4. And to make those match, multiply by negative. -4 times 2, -8. Just like it says, no remainder. Nice. Now, 12, see if that binomial is a factor. Now, when you divide, you would get no remainder if it is, and I didn't explicitly say use the remainder theorem, so I suppose you could divide. But like we just went over, I am checking if that's a factor. If it doesn't say, hey, you have to divide, you can just plug in, the solution you would get from that binomial. Just like when we solved that quadratic up there. K equals 2. You just plug that in, substitute it in for K, and especially when you have a calculator. Don't have my calculator open. 1 second. 1 second. I apologize for the delay. Come on. There we go. All right. So we got 2 to the third. Hit over to get out of that exponent. Plus 3 times 2 squared. That one automatically pops you out. So minus 6 times 2, minus 17. That gives you the same thing as the remainder. Remainder is -9. Now I'll go back to smartboard window here. Remainder would be -9 if I did that division, so nope, not that. And I believe that was, yes, that was it. There we go.